You asked an AI a question, the answer came back instantly, fluent, confident, detailed, and then you checked it and it was wrong, not slightly off, completely fabricated, a court case that never happened, a research paper that does not exist, a statistic pulled from thin air. This is an LLM hallucination. It is one of the most misunderstood problems in AI, not because it is complicated, but because it is deeply counterintuitive. In this lesson, you will learn exactly why it happens at the level of how every single word in every response is actually produced. No jargon, no code, just the real story. An LLM hallucination is when the model produces text that is confidently stated but factually incorrect, invented, or entirely made up, without any warning or signal that something is wrong. This is not a subtle problem. The model states falsehoods with the same smooth, authoritative tone it uses for perfect truths. Hallucinations are not lies. The model has no intention, no concept of truth, and no awareness that it is wrong. It is not trying to deceive you. It simply cannot tell the difference. Hallucinations include wrong historical dates, invented book titles, research papers that do not exist, laws that were never passed, people who were never born, and events that never happened. The most dangerous hallucinations are the most convincing ones. Fluent sentences with the right format, the right tone, just the wrong facts. Imagine a brilliant student who studied nothing before a final exam but refuses to leave any question blank. They write full, confident, grammatically perfect answers, blending things they remember correctly with things they half remembered, guessed, or constructed on the fly. The paper looks excellent. Many answers are right, but some are completely invented. And from reading the paper, you cannot tell which. That is an LLM on every question you ask it. To understand why hallucinations happen, you need to understand exactly how the model builds every single response, and the process is simpler and stranger than most people imagine. It all starts with your prompt, the question or instruction you typed. The model immediately tokenizes it, splitting your text into small numbered chunks called tokens, not words but fragments. Then comes the core step, predict. Given everything seen so far, what token most likely comes next? The model runs this question against billions of learned patterns and produces a ranked probability list of every possible next token. It then picks one, pick one token, the highest probability option wins and gets appended to the growing output. That single token becomes part of the growing answer in extend output, and the entire process repeats. The new output fed back as input for the next prediction. After hundreds or thousands of these rounds, you have a full response. Here is the critical insight. There is no separate fact checking step anywhere in this loop. There is no node labeled verify this against reality. There is no pause to consult a database. Just predict, pick, and repeat hundreds of times until the response is complete. Every word you read, right or wrong, is the result of this loop running hundreds of times. Here is something that changes how you think about everything else in this lesson. To the model, the sentence Neil Armstrong landed on the moon is not a fact about an astronaut, it is six separate numbered tokens. The model learned patterns about those token sequences from its training data, not facts about the actual person or event. It knows that the token sequence Neil Armstrong is statistically followed by certain patterns of tokens, and it uses that statistical knowledge to predict responses. Now look at a word like anti disestablishmentarianism. The model has never encountered this word as a whole. It splits into seven tokens: anti, dis, estab, lish, meant, Aryan, ism, and the model processes it as pieces, predicting what typically follows each piece based on the training patterns it absorbed. This is the single most important insight for understanding hallucinations. The model operates on patterns of tokens, not on a stored map of reality. It does not have a database of facts. It has a statistical memory of which tokens tend to follow which other tokens. Common tokens in well documented contexts are predicted reliably and accurately, but rare tokens, obscure names, specific numbers, and recent events that appeared only rarely in training data, these are predicted by extrapolation from similar patterns, and that extrapolation is exactly where hallucination begins. Your smartphone keyboard has an autocomplete feature. As you type, it suggests the next word. It learned those suggestions from millions of messages, so it knows that happy is usually followed by birthday and see you is usually followed by soon. It has no idea if what you are typing is true. It only knows what words typically follow other words. An LLM is this exact mechanism, scaled to an almost incomprehensible degree, trained on hundreds of billions of words from books, Wikipedia, research papers, news articles, forums, and websites. Every pattern it has ever absorbed compressed into billions of numerical parameters. When you ask what is the capital of Australia, the model does not look it up. It runs a pattern match. In all the text it was trained on, capital of Australia was overwhelmingly followed by Canberra, so Canberra wins. For common, well documented facts, this works beautifully. For obscure facts, rare names, or specific numbers that appeared rarely in training, the model extrapolates from similar patterns. And that extrapolation is the exact mechanism that produces hallucinations. Imagine you read every book, article, newspaper, and tweet ever published in 10 languages. Then you lost all access to the internet, all books, everything. You can only use what you absorbed. For well known facts, you get it right. But for an obscure date or a statistic you half remember from one article, you fill in the gap with whatever pattern felt right. You do not know you are wrong. You sound completely confident. That is an LLM answering every question. When you dream, your brain constructs a vivid, convincing, detailed world. Conversations feel real, places look real, events follow their own logic, but none of it has been checked against reality. Your brain is generating a coherent narrative from fragments of memory and imagination with no external verification. LLMs generate text the same way. Every sentence is maximally fluent, grammatically perfect, and internally consistent because the model was trained on human written text that is fluent, grammatical, and consistent, so it learned to produce more of the same. The problem is that fluency and accuracy are completely separate properties. A text can sound perfectly natural and be completely false. The model optimizes for the former. It has no direct mechanism for the latter. This is why hallucinations are so convincing. The model is essentially perfect at making text sound right. It learned this from billions of examples of confident, fluent human writing. It reproduces that confidence and fluency regardless of whether the underlying claim is true. Give a talented novelist the task of writing a biography of a real but obscure historical figure working only from memory, no notes, no internet. The result would be beautifully written, internally consistent, full of convincing period detail, and some of it would be invented, not from dishonesty, but from the brain filling gaps the way it always does. The fluency of the prose gives you no signal about which parts are accurate and which are constructed. The LLM is that novelist for every single response. Let us look at what hallucinations actually look like in practice because knowing the types helps you spot them. A factual error is the most forgivable category. A date off by 1 year, a name slightly wrong, like claiming Columbus reached America in 1491 when the answer is 1492. Tiny, plausible, and easy to miss without domain knowledge. An invented citation is the most professionally dangerous type. The model has seen thousands of academic papers, so it learned exactly how citations are formatted, how abstracts are written, how findings are phrased, and it generates a perfectly formatted fake complete with journal name, volume number, and author style. No such paper exists, but it looks exactly like one that does. A wrong number highlights a critical insight. Numbers are just tokens. When the model writes 330 meters or 450 meters after Eiffel Tower it is not computing a value from a database. It is predicting what number token typically follows in the text it was trained on. False authority is the most insidious type. The model learned that authoritative sounding text includes phrases like according to, studies show, and guidelines recommend, so it generates those phrases naturally with no underlying real world source behind them. Every type shares one root cause. The model predicted text that statistically fits the context. It did not verify the claim. The scale of the hallucination problem is larger than most people realize, and a few numbers make this concrete. Approximately 20% of academic citations generated by LLMs in recent studies point to papers that do not actually exist. That is not an extreme edge case. It has been reproduced across multiple studies using different models and different prompting approaches. The most important number is zero. There are zero internal fact checking steps inside any standard LLM. Generation and verification are completely separate mechanisms. The architecture does not include a step called check if this is true. Generating text and verifying facts are two completely different engineering problems, and only one of them happens inside the model. 100% of all LLM responses, correct and incorrect alike, are produced by the exact same token prediction engine. Every correct answer you have ever received was produced by the same mechanism as every wrong one. You cannot tell from the output which category you are in. Finally, research suggests a roughly 40 times higher hallucination rate for obscure or rarely documented facts compared to common, well covered knowledge. This is why specialists are most at risk. A doctor, lawyer, or researcher asking about specific domain facts is in precisely the territory where training data is sparse and extrapolation is highest. The model does not know what it does not know, and that is the whole story. A human expert who does not know the answer to a question usually feels some signal of uncertainty, a pause, a hedge, a note to check later. The brain has a rough metacognitive awareness of what it knows confidently versus what it is uncertain about. An LLM has no equivalent signal. There is no part of the model that represents I am confident in this versus I am guessing here. Every token is chosen by the same probability calculation, regardless of whether the underlying claim is well documented or entirely invented. The model's training rewarded producing fluent, grammatical, human sounding text, not producing uncertainty signals. Most human writing is written with confidence, so the model learned to write with confidence. This is the hardest part of the hallucination problem to solve. You cannot simply ask the model to flag things it is unsure about because the model genuinely does not have access to that information about itself. Imagine you could only speak in fully formed declarative sentences. You physically could not produce hedging phrases like, I think, I am not sure, or you should check this. Every sentence that came out of your mouth would sound equally certain. You might know something deeply or barely at all, but the listener would receive both with the same confident tone. That is every LLM on every topic, in every response. The confidence is not arrogance, it is an architectural reality. The deepest reason hallucinations are so surprising is a fundamental mismatch between what people assume about how the model works and what actually happens. On the left, what people assume a fact retriever. Most people come to AI tools with an intuitive model. The system learned facts, stored them, and retrieves the right one when asked. Wrong answers mean a gap in the database. Confidence means certainty. It works like a very fast, very smart search engine. This is not a silly assumption. It is the natural way to think about a system that seems to know everything, but it is architecturally wrong. On the right, what actually happens? A pattern predictor. The model learned statistical patterns from text about the world, not facts themselves. Asking a question triggers pattern completion, not retrieval. Wrong answers mean the pattern was misleading, structurally indistinguishable from right ones. Confidence is a stylistic artifact of training data, not a signal of correctness. It works like a supremely well read person who cannot look anything up. This right panel explains why hallucinations are not bugs to be patched. The model is working exactly as designed. Pattern prediction produces fluent, statistically plausible text. The practical implication is direct. Never use an LLM as a primary source. Use it to organize, write, reason, and draft. Then verify any specific factual claim against an authoritative source before acting on it. Andrei Karpathy, AI researcher and former director of AI at Tesla and a founding member of OpenAI, has described the nature of LLMs in a way that no technical description fully captures. Quote, LLMs are not databases, they are dream machines. They generate coherent text the way a dreaming mind generates a vivid world, fluently, confidently, and without a ground truth tether. End quote. The absence of a ground truth tether is not a flaw in the design, it is the design. The model was built to generate maximally coherent, fluent, human like text, and it does this extraordinarily well. What it was not built to do is verify whether that text corresponds to reality. The implication is not that LLMs are useless, they are enormously powerful for drafting, reasoning, summarizing, and explaining. But you must understand what you are working with a pattern prediction engine that dreams in your language. not an oracle that knows the truth. Techniques like retrieval augmented generation, giving the model verified facts to work from, can reduce hallucinations significantly, but even these approaches reduce, not eliminate, the fundamental behavior. The dream machine still dreams, understanding that is the beginning of using these tools wisely. Let us bring it all together. A hallucination is not a lie or a bug. It is what happens when a pattern prediction engine produces the statistically likely continuation for a prompt where the real answer requires verified facts the model does not have. Every single token in every LLM response is chosen by the same mechanism. Predict what most likely comes next. Correct answers and invented ones are structurally identical and produced by the same process. The model has no internal fact checker, no uncertainty signal, and no way to distinguish what it genuinely knows from what it statistically predicts. This is an architectural reality, not a calibration problem. Hallucinations are worst for specific claims, exact dates, named citations, precise numbers, obscure figures, and anything that happened after the model's training cutoff. These are the facts where training patterns are sparse and extrapolation is highest. You can reduce hallucinations by grounding the model. Give it the facts you want it to use directly in your prompt, ask it to quote sources you provided, and always verify specific factual claims against authoritative sources before acting on them. The next time an LLM gives you a confident answer, ask yourself, is this the kind of claim that appears thousands of times in its training data, or the kind that appears rarely? Use LLMs for what they are extraordinary at: drafting, reasoning, summarizing, explaining. Use authoritative sources for the facts. In the next lesson, we look at retrieval augmented generation, or RAG, giving the model verified facts to work from instead of asking it to guess.